So in this problem, one object is colliding with another, the second object not moving. Instead of given how fast one object is moving and its angle, you're not given either speed, so the magnitude of the velocity of either one of these objects after the collision, but you're given the angles. So just note the diagram. The dashed objects are after the collision. The non-dashed objects are before the collision, and there is a little tick mark there indicating after collision as well. Set it up the same way. So start by setting it up the same way, x direction, y direction. So I'll start with analyzing all parts of this problem in the x direction. You have to analyze it with what's happening before the collision and after the collision. So I'm going to write that down. Before. Now, we've been using object A and object B, but this already has 1 and 2 in it, so I'm going to leave it that way. Note before we get too far into this, as I said it earlier in class, the two masses are equal. Okay, so these objects are like pool balls. They have equal masses. In the momentum formula, every single m would be exactly the same, so you could divide it out. So I'm not even going to incorporate the masses into the problem because they are equal to each other. If they were not equal to each other, of course, keep them in. And you'll have some examples like that. We can do one of those tomorrow if you want to. So before the collision, object 1, is moving, and I already forget, 8 meters a second. Object 2 is not moving, 0. Remember, the masses are the same. They're just going to divide out of our equation. I'm not going to write them down. After the collision, this is where we have to be careful. Object 1 in the x direction. I forgot my x's. I always forget. It's so easy to forget my x's. In the x direction, prime. So object 1 in the x direction after the collision, we do not know what that is. I'm purposely just going to leave it like that for the time being. I'll come back and I'll show you why the math is a little bit different. Object 2, make the v's the same way. Object 2 in the x direction after the collision. Don't know what it is. Okay? Don't know what that is. Now we are given the angles. I'm going to come back to that in just a few minutes. So let's set up our momentum, conservation of momentum formula. Now I'll write it all out at first. I'll use my masses, m1 v1x plus m2 v2x equals m1 v1x prime, m2 v2x prime. So before the collision, momentum equals after the collision. Each mass here is the same. So if we had a number, if you want to put a number in, you can put a number in. They're all 3. It doesn't really matter. You can just divide everything by 3. You still have the same math equation. So this problem is a little bit easier. We're just analyzing velocities. I'll put my numbers in. Before the collision, velocity was 8. Velocity 2 is 0. It wasn't moving. After the collision, v1x prime plus v2x prime. We don't know either of those. No help. When you're solving math equations and you have one equation and 2 unknowns, you're done. You can't go anywhere with that. You can get a relationship, you can get a formula, but you can't actually get a value for each of these. So I'm just going to leave it right now and I'll come back to it. Set up the y direction. Okay, set up the y direction. In the y direction, again, ignoring the masses, velocity of object 1 in the y direction is 0. It is not moving up or down the way we've got the problem set up. Object 2, y direction, 0. So the velocities in the y direction before the equation are 0. So the momentum is 0. So that means after the equation, the total momentum in the y has to be 0. So however these things are moving, the two velocities have to add to be 0 as well. So this is before. Forgot to write it in. before the collision, after. Once again, V1y after the collision, don't know what it is. V2y after the collision, don't know what it is. Let's write our equation down. 0 plus 0 equals, masses all divide out. I'm not going to write them in again. That's as far as we can go with that. Everything's 0 beforehand. Now the problems we are going to be doing like this, there will not be any initial y. So it'll always be 0. Kind of keep things a little bit easier that way. But the two components have to add together to be 0. But again, it's one equation, one unknown. So now we start looking, if you look at what we have with the x, the relationship of the velocities in the x and the relationship of the velocities in the y. Two equations. How many unknowns are there? 4. Still no help, right? And you guys are good at math, but not that good. You can't solve. No one's that good. You can't solve for 4 unknowns. This is why the angles are given. The angles are given so that we can eliminate 2 of these variables and rewrite the problem with only 2 unknowns and 2 equations. So I'm just going to do that down the bottom. So when you go to solve your own problem, you can do this at the start. I just wanted to show you where the math comes in and where you could get stuck if you are only using components. Right? V1x prime is the velocity of object 1, its magnitude after the collision, right? Cosine, its angle, 48. Let's go to, I wrote 78. Oh, why would 78? I said 48. Check the tape, rewind it when you're watching this. 48. Object 1's y velocity after the collision is its magnitude sine 48. Let's do object number 2 after the collision. Oh, no x. Yeah, I want x. I want x. Is the magnitude of object 2 after the collision cosine 42. Object 2's y component after the collision is its magnitude of its velocity after the collision sine 42. Now, does anything need to be negative? Because we're taking a component and writing it as its magnitude, sine or cosine. So look at your diagram very carefully. Are there any negative components? Yeah, V2, its component is going to be down. It's going to have to be negative. So that's a little bit new. We're breaking something up. We're writing a component as the magnitude, sine or cosine the angle. You have to check for that. So right here, that's going to be negative. We're going to take the 2 equations from above and replace it with all of this stuff. I told you guys yesterday, I hope you like substitution. I know. So I'm going to rewrite it. So it's 8 equals the x components. I'm rewriting just to remind myself what they are, and then V1, V2x. And it's 0 equals the y components. V2, V1y. So many subscripts. Now let's replace what they are and using the angles. Okay. Remember, the angles are just going to be numbers. You can put them in your calculator. I'm going to do that later on. Okay. Again, this question is longer to work out than you would normally take. You would normally start with what I'm doing right now. You would set up your equation, break up your components into its magnitude, and incorporating the angles right away. Easy. There we go. So 8 equals V1x is V1 prime cosine 48, not 78, plus V2 prime cosine 42. Okay. And then in the y direction, we have 0 is V1 prime sine 48 minus Right? It's a negative. I'll put it as plus because I formula plus, but it's a negative v2 prime sine 42. Two equations, two unknowns. Now we can have at it with our math. So you have to solve one equation, substitute into another one. Which one do you want to solve? The one with the zero. Yeah, if I called this equation 1, if I called that equation 2, you would solve equation 2 because it's less complicated when you do the substitution in the next step. So I'm going to do that. I'm going to solve equation 2 for, what do you feel like, V1 or V2? V1. V1 prime after the collision. All right, done and done. So I'm going to add the V2 to both sides. V2 prime. I'm just going to work out the numbers now for the signs so we have them rather than having to write out sine 42 all the time. 0.669, so 0.669 V2 prime equals V1 sine of 48. 0.743 V1 prime. Okay. So I've added the V2 sine 42 to both sides, and now I'm going to divide both sides.
You hit like sine 48.
Yep, I hit sine 48 and hit sine 42 in my calculator, just to have the numbers in. Because it's not like the projectile problems where it simplifies to tangent or anything like that. They just need to work them out. So divide both sides by the 0.4743. Divided by 0.7. 0.9. And V2 prime equals V1 prime. We've solved it. Okay, solved for V1 prime. Substitute that into 1. Careful with this step. Careful with all steps, you know what. 8 equals, it was sine, I'll write it out, cosine. Cosine 48, so I'm going to just work out cosine 48. 0.669, wow, complementary to the other one, right. 0.669. That's the cosine of 48. Remember, it was multiplied by V1 prime, but V1 prime is 0.90 V2 prime. Right, there's my substitution step. And plus cosine 42, which is going to be 0.743. 0.743 V2 prime. The actual mathematics, not too bad. You guys are doing more complicated stuff in your math, but obviously the steps to follow, there's lots of them. Okay, so be very careful. As always, show all your work. Like, you are not going to get 0 if you make a little mistake and just happen to forget the negative as you're working through, or you write a number wrong, or you put 42 where you're supposed to put a 48. That kind of stuff happens to me like 5 times so far this problem. So just be careful. I'll work the rest of it out. I'll simplify. I'm just going to, remember, these are like terms. I'm going to put them all together. So it's 0.669 multiplied by 0.9 equals that. Add to that 0.743. So this is 8 equals 1.34. Yeah, 1.34 V2 prime. Divide both sides by 1.34. 5.9. Almost done. Solve for V1 prime. Remember, we made an equation for V1 prime already. We're just going to use that because V1 prime is just 0.9 times V2 prime. Why is it that? It's our first equation. We had 2 equations. We rearranged one equation to solve for a variable. There it is. We're going back to that. Yeah. Yeah, it's 0.9. 0.9.
Where is the 0.669?
That is cosine of 48. It's just from one of the equations up, so I'd have to write it down again. Whoops. Oh, I did that. V1 prime 5.4, V2 prime 5.9. All right, so quick recap.
Is that 2?
Yep.
Like the 0.9 V2 part?
Right here, yep.
No, no.
Oh, here,
So up.
yep.
That's a 2?
That's a 2.
Okay.
Yep. Right there. So recap, set everything up like you normally would. But do this question a little bit different as I went through it for you, because I wanted to explain why we do the substitutions. When you're setting up your x direction and your y direction, don't leave it as v1x. When you guys go to set this up, you'll save a lot of the steps by immediately writing v1x as just v1 prime, v1x prime as v1 prime cosine, whatever angle's given. Do that immediately for all your components. Use those values when you're doing your momentum equations. You'll have less steps to do as you're going through this. I just wanted to show you why we had to do it, because we end up with 2 equations and 4 unknowns. The math does not compute. So same thing for this one. V2x prime is going to be V2 prime cosine 42. Do the same thing in your y's. So use these values with the cosines and sines before setting it up. You'll have just less steps to work through. Okay, believe me, these questions do go faster, but you have to practice a couple of them.